Hello, we will introduce the SmartTags utilized in the DigInTraCE project. SmartTags are visible or electronic markers with environmental sensing functions, combined with software intelligence to provide context-aware services to the end users and enable the connectivity to the Internet of Things. The SmartTags consist of a data carrier that provides item-level identification and access to data stored into databases or in the cloud. In addition, there is a sensing solution that monitors selected environmental or product conditions during product lifecycle. During the DigInTraCE, we have further developed the smart tag reading functionalities and data management solution. We will now present these advancements. Let's start with the general requirements for the smart tag reading application. Because SmartTag in many cases operates as a data carrier for digital product passport, the compliance with eco-design for sustainable products regulation is of utmost importance. Based on the regulation, DPP data must accessible via open web standards. Anyone should be able to scan a QR code with a standard device and instantly view the product's information without needing a special application. We thus prioritize web-first, mobile-friendly solutions using progressive web apps (PWAs) to avoid native app installations. The SmartTag PWA app offers extra features for visualizing the tag observations, but also a public web link to DPP data, which is always available for compliance. In practice, when using the SmartTag app, a user just scans the QR code with the mobile phone. No prior native mobile application installations are needed. The user will be redirected to the website showing basic DPP data. If the user also wants to see information interpreted based on the visual changes of a smart tag, he or she takes a picture of the tag, and the SmartTag app visualizes the results or optionally gives verbal interpretation of the tag's status. In this picture, the implementation architecture of SmartTag application is shown. The application is able to communicate both with DigInTraCE DPP platform and optionally also through EU-compliant dataspaces. Use of dataspaces enables stakeholders to share data in a secure and self-sovereign manner, having full control how possibly business-critical and sensitive data are shared. SmartTag user interface can be tailored to visualize relevant data based on the use case-specific requirements. In this first DigInTraCE iteration, the UI shows interpretations of the tag sensor data. On the right side of the app, there are components related to Asset Administration Shell, AAS, which can be utilized as a standardized database. The highlighted sequence declares how a user, such as a human or a robot, with some device, possibly mobile phone, scans a smart tag attached to the product and gets the URL that the smart tag provides in the form of QR code. As stated earlier, no pre-installation of SmartTag application for a customer is needed. Based on the URL, the SmartTag user interface is fetched and can then be used for scanning the sensor data of the smart tag. Sensor data of the smart tag is then processed and sent to the DigInTraCE DPP platform for storing them in the corresponding DPP. SmartTag app can later, if needed, also read various data from the DigInTraCE DPP platform. These data can be about, for example, the historical sensor data or other product passport data of interest. Here, the operation of the SmartTag app is demonstrated in the scanning phase. When the QR code is detected, besides the URL, the library also returns result points that are visualized in the view. Based on the unique ID and the result points, the sensor data can be interpreted. The unique identification of SmartTags follows the identification link standard, which defines a framework allowing organizations to self-issue globally unique identifiers and embed them in resolvable URLs. During the implementation of the UI, some further development needs have been identified. First, the selected barcode scanning library seems to be moved to maintenance mode, indicating the need for more advanced scanning library with regular updates. This aspect is also amplified by the fact that the current library does not support detection of multiple barcodes simultaneously. Secondly, a functionality for feasible linking of DPP tag and SmartTag has to be built. At the moment, these tags are separate instances. However, in future, they can also be combined. In DigInTraCE project, also the SmartTag data model was further developed to enable wider usability, interoperability, and extensibility. The data model builds on previous research, but expands it towards supporting standardized data representation and multi-condition sensing. In addition, the SmartTag ontology has been mapped to the Asset Administration Shell, the standard for digital twins in Industry 4.0. This enables modular and interoperable representation of identification and observation data, supporting also integration with manufacturing ecosystems and dataspaces. In DigInTraCE, the sensor development has focused on two main indicators, humidity and aldehyde. Both use color-changing inks to visually signal environmental changes. For humidity, the indicator responds to low relative humidity levels, while the aldehyde sensor detects formaldehyde concentrations, relevant for regulatory compliance in wood-based products. The development of the SmartTags will continue in the use case-specific tasks. Thank you for your attention.